Hello, my name is Ifeanyi Roland Onyoako, and the title of my project is Malthus Population Model with Disease Death Rate Consideration. This comes from the review I have done from the paper, Anubhav Singh's paper, which is titled Study of Mathematical Models for Thomas R. Malthus Model. Now, in this paper, they discuss three different techniques of population prediction, which is of course, Malthus model, the logistic model, and the correlation model. However, for the sake of my project, we will be paying attention to the technique and solution of using the Malthus model. Now, in this case, he used the main agents were growth rate and time, and he used that to predict for India's population from 1942 to 1972, and of which he felt it was efficient. However, there are different factors that were not paid attention to or factored in during this population calculation. Now, where our project focuses, we know that a lot of things affect population, which is education, poverty, diseases, technology, population density, and all that. So, however, in our paper, due to time constraint, we'll only pay attention to disease death rates, the disease-induced deaths. Now, and of course, we're paying attention to the top 10. We'll get our data from the top 10 death-related diseases in the US of A. To break it down, our agents will break it down to the reproduction rate, of course, disease death rate, and we are introducing this parameter variable called random disease generator. Random disease generator is literally after a couple number of years, we put in, let's say, oh, this particular year we have a new disease. How does this affect the population growth? How does it affect the calculation, the equation that has been created to predict population size? So this project is to show a more realistic population prediction model that would be able to factor in sudden changes in reality, sudden changes in our environment that would cause disease deaths. And how does that affect our prediction? Does that affect the real population? And thus, at the end of the day, we'll check and calculate, and we'll compare what the population prediction numbers and the actual data. The environment we'll be testing out this on the country USA, and then I'll be using NetLogo to implement this model.